Okay, so how do we know where these electrons will go? What orbitals they'll be in, what sublevels they'll be in? Knowing what their energy level is pretty straightforward, but what about their sublevel? What sort of orbital shape are these electrons going to be in? Well, before we get to that, we have to know some basic rules. And for electron configuration, we're configuring where these electrons will go. There's three rules which we'll go over: is Aufbau, Pauli exclusion, and Hund's rule. So the Aufbau principle is the electrons will occupy the orbitals of the lowest energy level first. So they'll go to the first energy level, then the second, third, etc. So Aufbau, how to remember that? You bow. When you bow, you go to the lowest. You bow. You're at the very lowest energy level. That's Aufbau. And these rules will become more apparent, and you probably think, well, what the heck are you talking about? Well, when we go through it, I think they'll become more apparent and obvious. The Pauli exclusion principle. So atomic orbital have at most 2 electrons. So each orbital will have at most 2 electrons, each with the opposite spin. And I think this was Pauli from the Jersey Shore who came up with it. And people probably don't realize what a brilliant theoretical chemist Pauli is, and physicist. So I think we have to give him credit. I think that's the Pauli who came up with it. Then there's Hund's rule. Every orbital in a subshell is singly occupied with 1 electron before any 1 electron is doubly occupied. All electrons will have the same, and singly occupied orbitals will have the same spin. This probably means nothing right now. Let's get to some examples first, and then it will make more sense. Before we get to the example, let's look at an analogy of how we place people in apartments. Here's an apartment I used to live at, and it was a pretty cool apartment. But they fill up apartment rooms just like they do electron energy levels. When the first person came, it was a brand new apartment building, the first person comes, and we have to go to the Aufbau principle. Aufbau principles, electrons occupy the lowest energy level first. So that first person goes to the lowest energy level here. Doesn't matter if he wants to go to the top, he has to go to the lowest energy level first. Now the second person that comes in will also go to the lowest energy level. There he goes. This is also Aufbau principle, but it's also the Pauli exclusion principle, because we have opposite spins here. They're kind of spinning in different directions. This one's going this way. This one's going this way. They're spinning in different directions. So what if we get another person in? Well, in the first energy level, we can only have 2 electrons at most. The second energy level will have a different. Here's the second energy level, but he has to go to the next lowest energy level. This first energy level is filled, he goes to the next energy level. And what happens if we get another person in? Well, he's not going to come here, he's going to go to the next available, because here she does not like the situation. So she goes to her own room. She doesn't want to deal with this situation. And notice their spins are going to be the same. That's Hund's rule. 1 electron will enter each orbital until all orbitals contain 1 electron with the same spin. So that's like the rooms. So the orbitals, in a sense, are like these rooms, and they'll keep filling up the orbitals or the rooms until they have them all filled up with 1 person. So we have another person. She doesn't really get along with this girl, and definitely she doesn't get along with the situation. Sammy Sweetheart does not get along with the situation or the Snooki. And here we go again, Hund's rule, Angelina, or Angeline. I can't even remember. But she was my... Yes, Angeline was I think everyone's favorite. Definitely my favorite. All the orbitals are occupied, singly occupied. So now, the next person in is going to have to double up. The next person in is going to have to double up and have a different spin. And here we have Ronaldo. So Ronnie has to go into the next room. That's his only choice. He has to room with the situation and spin opposites. And then we're going to fill them up. Here we have JWoww, who's going to go in with Snooky. That makes it fine. Dina is going to go in with Sammy Sweetheart. Notice their spins are opposite, so they're filling up. And only person who would really live with Angeline or Angelina is, I think, Hannah Montana. So what happens if someone else wants to live? Well, this second energy level is filled up, so we have to go to the next energy level, and that's where I came in. I was the only one in that energy level, and that's what stayed empty. So there we have the three rules, and let's look at a real example. Okay, so these are off-bow diagrams, and these are easy ways in which we can visually see it and then also place electrons within an atom. So let's look at atoms. Let's just look at hydrogen. We can do any atom. It's just fun. You can do it with any of your friends, your parents, your siblings. Bring an off-bow diagram, bring a pack of them to parties, and you will be, I promise, the most popular person at that party. So hydrogen is 1, 1. Protons, all we care about the electrons here. So that has 1 electron. Now we're going to put in an electron. Electron we can symbolize as an arrow, up arrow, down arrow. I usually, and many people do half arrows. So when you start drawing these, you just want to do little half arrows. That's fine. So this, either this or this, will signify electrons. Hydrogen has 1 electron, and we'll just signify hydrogen. We fill up with a 1s energy level. So the s orbital in the first energy level, and that's hydrogen. That's it. That's where its 1 electron is. And we can see as we go up, here we're increasing energy. So the higher we go up, the more energy. And that makes sense. If you're higher up in an apartment building, you're going to have much more energy than if you were down here on the ground floor. Let's look at helium. Let's just go down the line. Helium has 2 electrons. Okay, we have the off-bow. We're going to do the lowest energy first. But if they occupy this orbital, they're going to have opposite spins. We can't have the same spin of electrons like this. Opposite spins. Now lithium has 3 electrons. So we fill up this first energy level, the 1s, then we go to the next one. We go right up in this apartment, and we have, there we go, we have the 2s. And that's lithium. Let's look at beryllium. B has 4 electrons. So where is that 4th electron? Well, there's room here. He's sorry, they have to room together. If they're friends, that's great. If they're not, that's not so great. So now we have 4 electrons. Let's try the next one. Boron, 5 electrons. So this has 4 electrons here. The next one goes here to the next energy level. So this also shows not only the off-bow principle, but the Pauli exclusion principle. At most, you can have 2 electrons, but with opposite spin. 2 electrons opposite spin, 2 electrons opposite spin. Now, if we look at the next element, which is carbon has 6 electrons. We're going to have to look at Hund's rule. Electrons will occupy orbitals of the same energy level in a way that will make the number of electrons with the same spin as large as possible. So we're going to have the same spin here. So that's 6 electrons. The next we'll have nitrogen, 7 electrons, and that's going to go here. And this makes sense as if you were like rooming in a dorm. If you had the choice of being in your own room or rooming with someone else, you're going to probably room in your own room. Also, like a bus analogy, if you're in a bus, you're going to, if you can, you're not going to sit next to some total stranger. You're going to sit, all the double seats will fill up with one person first. And once those are filled up, then you're going to start doubling up. Oxygen has 8 electrons. So we have 4, 5, 6, 7. And then where is this oxygen going to go? It's going to go right here. Then 7, 8. So now this has 8 electrons. Let's look at fluorine. 9 electrons. And so we'll go here. And then neon, 10 electrons right here. Opposite spins with their electrons. Now this is filled up. Neon is filled. And this also will make sense when we get to noble gases and what makes stability. Okay, let's try a more challenging one. Let's just try chlorine. Chlorine is 17 electrons. So we start filling up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the next one after 10 is going to the 3s. The lowest first. So that's 1, 2, 3, 4, 5. That is 12, 13, 14, 15, 16, 17. And there we have chlorine. 17 electrons. Let's try an even more complex one. What about cobalt? 27. See if you guys can do this. And if you want to go along with me here, in your OneNote chapter 5, there's off-bow diagrams. You can try it there. There's a bunch of off-bow diagrams. You can just try it along with me as I do it in your chapter 5 OneNote tab. So 27 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now after the 3p we go to the next lowest one. So you have to see which is the next lowest one. The S, the 4s, is lower energy than the 3d. That might seem a little odd. Well, shouldn't you go to 3d before 4s? No, because the 4s is lower energy. So we have to go here. Then after the 4s, we go to the 3d, 21, 22, 23, 24, 25, 26, 27. Okay. Now, there are, within the transition elements, there are going to be some that don't exactly follow this rule. But for now, we're not going to worry about that. There are some exceptions, but we're not going to worry about that right now. First, we're just going to fill it in order. Let's try lead. So lead has 82 electrons. Okay, so 82. And we go from the lowest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 6, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82. Might have miscounted. I'm really just trying to show you how this all works. There are, again, some exceptions to this configuration, but we're not going to talk about that right now.